Hi everyone, this is Shivani here representing Group 4 for Project Sprint 2. First of all, I would like to thank my team for giving me an opportunity to talk about our presentation followed by Darshan, which is creating multiple linear regression models of 4 different time periods, including the introduction, model analysis, validation, prediction, and conclusion. Moving forward towards the introduction of the baseball history, baseball is a bat and ball sport with roots dating back to the 18th century, and it gained its popularity very rapidly and became an integral part of the American culture. The formation of the professional league, such as the National League in 1876, marked as a significant milestone, which is very interesting. Business questions that we will be covering in this PowerPoint are offensive or defensive variables better predictors of team performance, and the objective of this presentation is to create the multiple linear regression models as I mentioned before, evaluating each of their 4 regression models and selecting the independent variables that are good predictors of the games won. And at the end we will be using the 4th regression model from 1990 to 2010 and forecast the number of games won for the New York Yankees and the Toronto Blue Jays using the values for the independent variables for 2012 and 2015. Going forward, I will be showing you the 4 models that we will be talking about, which is 4 time periods: the dead ball era, which is period 1 before 1920, second period 1920 to 1960, the live ball era, period 3 1960 to 1990, the expansion era, period 4 1990 to 2010, the steroid era. Now all of 4 members of my group will be talking about each period in detail with their regression models. Here is a correlation heat map for all of the 4 models that we tested out. And I'll be showing it to you guys in my Jupyter file, my correlation analysis. So talking about the period 1, I have selected 5 variables, which is runs scored, hits, doubles, infield putouts, and shutout. Statistical significance of the period 1 that I have got. The model 1 was one of the best model that I have, which is on the right hand side of this slide that I have tested out, is runs scored plus shutout. R squared value I got is 0.853, which is a high R value, and this is a good indication that the model accounts for a high degree of variance in the data. Also, the p-value is 2.2e, which is statistically significant low. Moving forward to the Jupyter file that I have right here, this is the correlation heat map that I have already shown you guys. And these are the positive correlation to game ones. And here is the list of the linear regression models that I have tested out to get the best combination. And the best combination that I got out is the model 1, which is included in the PowerPoint. And here is the graph for the actual and predicted values of model number 1. Moving forward, I have these mean absolute error, mean squared error, and root mean squared error models in my PowerPoint that I'm going to show you guys right here, which is easy to locate. So right here, the model 1 in mean squared error has the lowest value, same as the RMSE. Model 1 is the best one, and same here in mean absolute error, the model 1 value is less than the other ones. So this shows the positive correlation of the variables that I have tested out, that model 1 is the best one that I have got so far. Passing on to Darshan for model number 2. Thank you.
Hello everyone, my name is Darshan. So for this project sprint 2, we have divided the work into 4 different equal parts as per the time period. So I was working on the period 2 from 1920 to 1960, which was also called an golden era for baseball history. So to analyze an actual and predicted game won for this time period, I have used different variables using the correlation graph. So first of all, I have imported all the data that is given for the baseball history from the starting. So after importing all the data, I have created correlation graph so that it's easy to select the variable. So I have selected the variable which has an value of more than 0.5. So in my case, the run score shutout, and for in the negative, the run against and on I have selected. And then I have tested the 6 different model using this variable. For example, I run score plus shutout, run score plus earned average, like all of this. Then I have created the regression model for all of the 6 models and find the R square value, F static value, P value, and T static value, and also find out the mean absolute error, mean square error, root mean square error. To select and best model, the R square value should be an higher. So in my case, the model 3 has an higher R square value for the model 3, it was an 0.91, and F static value was also higher, 2756. Mean absolute error was also 3.19, and root mean square was a 4.09, which were also the lowest among all 6 models. To graph for a visual representation so we can get a better idea, that you can see that the actual game one and predicted game one for this model is also similar. There is a less difference between this actual and predicted game one. So after testing all of the 6 models, we have selected the model 3 is the best model for a time period 9020 to 9060. So after analyzing all 6 models, I have created the graph for all of the mean absolute error, mean square error, and root mean square error for all the 6 models. So we can see that for my case, the model has the lowest mean absolute error, mean square error, and root mean square error. So and then I have also created the variance code different models. So you can see that. So we can see that the variance code is high for the model 3, and also the minimum error is for model 3. So the model 3 is based in my case for the time period 9020 to 9060. And for the conclusion, we can see that the model 3 runs score plus against has a base model which has an R square value of 90. F static value is higher. So I have selected. So after testing 6 model with the help of 4 variables, 3 defensive and 1 offensive variable, the model 3 was the base. So from the visual representation, we can see that the model 3 is the best for the, and thank you everyone.
Thank you, Darshan. Good morning, everyone. Let's move to period 3 between 1960 to 1990. In baseball history, this period also called as the expansion era. In this period, Major League Baseball expanded significantly. Major League added 15 new teams, including some big names like New York Yankees, Los Angeles, and Houston Astros. The era saw the rise of pitching dominance with a star like Sandy Koufax and Bob Gibson. They known as the strikeout leader in 1965. Also, pitching dominance led to the low-scoring games. In addition, the expansion era led to construction of new stadiums and the renovation of the existing one. It improved the facilities and expanding the baseball reach to the new market. Next, let's move back to our original question. Find the independent variables that are good prediction of games won. For that, out of all variable, I selected a 7 variable that directly impact on the games won. 3 of them are offensive and 4 of them are defensive. With the help of correlation heat map, I found this 7 variable which is positively or negatively impact the games won. Let me share my Jupyter file to explain you better. Okay, so here, so as you can see, with the correlation matrix heat map, you can see the run score is the closest to the games won positively. So you can see 0.67, then hits at 0.57, saves is 0.5. Same like if you compare the negative, then it's final standing minus 0.76, and on run average 0.48, run against 0.25. So with this criteria, I selected this 7 offensive and defensive variable. For the offensive, it's run score, hits, at bats, and for defensive, saves, run against, infield puts out, and on run average. Now, with that, I tested 18 different combination and find the best independent variable for the games. These are the 18 model I tested. It's a combination of offensive and defensive variable. Out of this, the best performing model is number 11, run score plus earned run average. As you can see, it has the lowest mean absolute error, it has lowest mean square error, and also root mean square error is the lowest for the model 11. And also if you compare for the explained variance score, then the model 11 is the highest and the max error is the lowest. So overall, it says that model 11 has the lowest error and run score plus earned run average has the best suitable variable for the games. Next, let's evaluate a regression analysis for this model. As you can see, model 11 achieved an R-squared value of 0.886. The F statistic is 1965. And the p-value is 8.19 E240. All this indicating its ability to account for a significant variance in the data. Also, if we see the standard error is 1.796, it's way lower than its coefficient 71.0061. In addition, this arithmetic analysis revealed Model 11's outstanding performance with the highest explained variance score 0.93 and the lowest max error of 11.88. All this deemed statistically significant. Also, from this graph, we can see that there is a positive correlation. So overall, we can assume that for period 3, 1960 to 1990, run score plus run average is the good prediction of a games won. With that, I'm passing over to Mabruk. Thank you.
Hello, everyone. My name is Mabruk, and I will be covering the period for future forecasting and the conclusion for my group's presentation. So for period 4, I tested a total of 18 models using 7 variables with a split of 3 offensive and 4 defensive. Beginning with a correlation analysis to determine feature selection, following with model creation and then testing and evaluation. That was the process followed for all of the models tested. Features were selected using the strongest positive and negative correlated values to our dependent variable games won. And the results of that are here. As you can see, I've charted the major error metrics for all of my models, as well as explained variance score, which is the dispersion of errors within the model, and the max error value, which is just the highest residual error found in the predictions. As you can see, the best performing model here is model number 11, using the variables run scored and earned run average, which is a mix of offensive and defensive. And on the right up here, you can see some of the statistics for that model, as well as statistics for the intercept and the 2 independent variables. So all in all, out of all 18 models, model 11, best one, mix of offensive and defensive. And that is the model that I used to run the predictions for the 2 teams and the 2 years, 2012 and 2015, on the Toronto Blue Jays and the New York Yankees. You can see the results there on the right. So for Toronto, both years had very good predictions, very close with a residual error of only 3.54 for 2012 and 2.36 for 2015. But unfortunately for New York, it did not perform as well, but it still performed fairly well. And overall, the model had a root mean squared error value of 6.93 on these predictions, which is pretty good, not amazing, not as good as the model had within the period data itself, but comparing to all of the models tested in period 4, it would rank 3rd for that value, so still pretty good. And you can see that I have charted the results for the prediction there as well, just for a nice visual, one glance look at how the prediction performed. Okay, so recap and conclusion. So all in all for this project, my team tested 50 models with 10 unique variables, and using those models, we found the 4 best for each period. And the variables for those models are listed below. So for period 1, we have runs scored at shutout, runs scored, runs against for period 2, And for the last two periods, we have runs scored and earned run average. And you can see that I've charted the error metrics for all four periods on the left side there. And basically, the entire overall question for this was what's better, offensive, defensive, or a mix? And I think the results are pretty conclusive here. The best model for all four periods used a mix of offensive and defensive. So that is the best thing to go with to impact team performance. In addition to the four best, also through all four periods, we saw the second best models having a mix as well. So definitely very conclusive results on that. And yeah, that's it for us. We will take questions and feedback now. Thank you.